All right, I think we're set to go here. Sorry, I was trying a different a different microphone, so I have my headset on so that you don't have to hear the keyboard clickety clacking. Welcome. I'm just gonna go back to credits real quick. So again, I'm Irene Pease with the Amateur Astronomers Association of New York. And this is some astronomy happening, your Thursday night dose of astronomy. So hopefully you've had a good week. I'm feeling a little bit punchy, so this might get a little dark. Kind of the theme tonight is the universe is trying to kill us. So just a heads up. If you want to tune out, I'll understand. But we're going to take a look at what's happening in the night sky. We're going to take a look at what's happening around our solar system, some of the news. If you have questions, comments, I try to keep an eye on the chat, but I'm still learning. So this is our view of OpenSpace. We'll come back to this in a little bit, but I like to start off with Stellarium. So we'll switch over to that. Here we have our view of now. We're looking at now. Again, Stellarium available at stellarium.com. And we have, yeah, right on time, 8:01. So let's go ahead and fast forward a little bit. It's cloudy in New York tonight. So may not be seeing a whole lot in the sky other than, clouds. But if it weren't cloudy, so like if there's no clouds where you are, good for you. This is kind of what we have. In the western sky, we still have Venus, really bright. Again, that's the really bright thing. It'll be getting a little bit dimmer over the next few months. More on that. So keep an eye on it, but it's the bright thing. I promise it's not a plane. It's really a planet that's up there. And we have the stars that we saw last time we talked about, Betelgeuse, Sirius, and Procyon, kind of fading as the spring comes along. Oh, there's a green thing. We'll have to come back to that. Last week I challenged people to find Leo, which is supposed to be this lion in the sky. I think it actually does look like a lion, even with the stick figure lion. So if you saw that, great. If you didn't, well, it'll be there for a while. And the moon is up there. So we're going to see the moon up close and personal-ish tonight using OpenSpace, because that's going to be part of our theme of the universe trying to kill us. And before we come to our marker, I also want to look at, the east and fast forward to morning. I've been doing this thing where I try to get up really early, sometimes more successfully than others. And a lot of times when I'm up early, I'm actually working, which isn't as exciting, so I don't actually go outside and take a look. But if you're up really early and you go outside and take a look before the sun comes up, or as the sun is starting to come up, there's more planets out there. So Venus is out in the evening, and then the other planets are out in the morning. So you can catch Mars, Saturn, Jupiter. Oh, look, and they're in a line. Coincidence? I think not. So those are out in the morning. So if you're an early riser, you can check those out. This is 4 a.m. because the sun comes up at like 5:30 now, 5:30. Early. It's up early. It's just going to get worse as we get closer to the summer solstice. So yeah, if you're trying to beat the sun, good luck. Anyway, I wanted to come back to that marker. I guess I need to rewind time a little bit for that. So we come back. Ooh, there's a marker. And marker. So this green marker, I put this in here earlier because I planned ahead. Believe it or not, I actually planned some of this. And this marker is set to the approximate coordinates of 1989 OR2. So you may have heard about that on the news. There's lots of news all the time. So in addition to the pandemic and UFOs, there's an asteroid that didn't kill us. So that's where this marker is trying to mark. It's in the constellation Hydra. There's Hydra. It's a big snake thing snaking across the sky. But yeah, it missed us. Yay. But I want to talk about all the other things, all its other little friends that are up there. So we're gonna see some of that tonight. And in case you're wondering, just here's a super fun, educational how to map the sky. So in Stellarium, you can put up these grids. This is our RA deck grid. So this is right ascension. These lines, these vertical lines are right ascension, and then declination is just like latitude on Earth. And then the right ascension lines are kind of like longitude, but totally different. And I'm not going to explain it all right now because it gets funky. But I just looked up the coordinates and it said it was at 11, 12, 36 right ascension. So this is 11, 12 ish. And then negative 30 degrees, 50 minutes, and some odd seconds declination. So this is, yeah, so there's the marker. So the asteroid, it should be bright enough to see in the sky if you have a good pair of binoculars and or a small telescope and a really dark sky. So it's not bright. You're not going to see it with a naked eye. But if you have binoculars, small telescope, you might be able to pick that out. If you have coordinates, you know where to look. It's out there, but it's not going to hit us. So that's my news for the night. No asteroid hitting us. So yeah, let's pop over to OpenSpace. OpenSpace. And oh look, there's the Earth. Blue marble. And I usually like to show some constellations. I might pass on that for tonight. We'll see what I feel like later. But yeah, this is the Earth. This is what the asteroid didn't hit. And actually that asteroid was really far away. Well, not really far. It was like 16 times the Earth moon distance from us. So it's not like it was in our backyard. I mean, there have been asteroids that have passed between us and the moon is like, was it 240,000-ish miles away. So that would be a close shave. But this other one, like way out there, okay, it's kind of exciting. And it's neat if you can see it. But very rarely do things actually hit the Earth because we have, well, a couple things going for us. So the good news in a little bit. First, the bad news that, the universe is trying to kill us. So if I turn on this data set, there's a bunch of small stuff in the solar system. And this may or may not break everything because there's a lot of data. I didn't mean to turn it on with everything right in the background. But yeah, so this is a whole bunch of small stuff, quote unquote small stuff. Pretty much any of these would be extinction events if they hit the Earth. Most of them. They're not that small. I mean, compared to a planet, they're small. But, compared to a house, maybe not as small. But yeah, there's a lot of them out there, and 1998 OR2 is one of these. It is in this data set. Don't ask me which one. I guess it's the one over towards Hydra. But this is meant to show you that, yeah, space is big, but there's a lot of stuff in it. And this is why we have, like, NASA and other people who track things that, could, create extinction events. So there's a lot. I want to go ahead and take a look at a certain view of this. If I could kind of flip this around or maybe just re-aim this. I'm going to re-aim at the sun here. So if we target the sun, put that in the center of our view, a tiny little sun, and come around for kind of a bird's eye view of the solar system. There's some really neat things that we see here. So one, yeah, be terrified. And also just, enjoy the science, the physics, that we can actually figure out where these things are going and how far away they are and whether or not they're going to hit us or if they're going to hit each other, or all kinds of fun things you can do with like a little bit of math, a little bit of science, mix them together. Good stuff happens. So I'm going to go ahead and turn on time for a few days per second. So we'll kind of fly through time here. Let's try 7 days per second. See if that breaks everything. Yay, it's not breaking. That's very exciting. These are huge data sets, so I get really excited when they don't break my computer and crash the stream. So we can see all these things, they're orbiting the sun for the most part, um, and there's might be some outliers that have some kind of weird effects in the data. So just ignore that. They're not really streaking in that fast. I don't think. I hope not. But some of the cool things that we can see here are that the things closer to the sun move faster. So that's something that gravity does. It's one of Kepler's laws of planetary motion that planets that are closer to the sun are moving faster, and then also for a given planet, as it gets closer to the sun, it moves faster, and then it's slower further away. So it's also a conservation of angular momentum. And I'm just kind of like waving my hands right now. So like if we look at one of these well, they're all little, but if we look at one that's further out here, we can see it just kind of like putting along. But the ones that are in really close are just really zooming around. So that's pretty exciting. So if we pause time, I think just the density of the trails make it look like there's a whole lot like really close in here. And I don't know if you can still see the Earth's orbit. I may have turned that off. Yeah. So there's the Earth's orbit. so so this is what Earth is trying to plow through. it's it's plowing through this mess. It kind of shares this region of space with, all this fun stuff. Um, so that's neat. But there's some reasons that we don't get hit with all this stuff. We're not just being totally bombarded. For one thing, I mean, again, space is big. So even when we had the so-called like near pass this last week, I guess it was Wednesday morning, the thing, didn't hit Earth, which was, really great. Uh, even with all these things flying around, something quote unquote close by, it's not really that close because space is big, and planets and asteroids and things are pretty small compared to space. They're small compared to our solar system. So it's a little perspective there. Another thing I always like to check out, like the orientation of things, like are these mostly in the plane of the solar system? So if we look and we can see all the orbits of the planet, so those rings are the paths that the planets take around the sun. So this is kind of looking in the plane of the solar system, and yes, all these smaller solar system bodies are mostly in the plane, but there's a lot that are higher up or lower down below it. So great. So they're all over, and that's just some of them. that's that's kind of the scary part. That's some of them. That's not all of them. Um, but there are people who are tracking these. So I think those are essential jobs right now. Those are essential jobs all the time, to have people tracking these things. So the next thing I want to check out, we're going to take a little tour. We're just going to stay in the solar system this week unless I get really inspired or someone has a question about, I don't know, whatever, stuff outside the solar system. But we're going to go ahead and take a little trip to another little planet called Mars. And I guess we can probably turn off all this other stuff that's around here. Mars is great. Mars is amazing. Mars, we have really great maps of Mars. So we'll have Mars Day sometime, because there's just so much cool stuff to see. And I'll try not to go off on too many tangents, but I might. So sorry in advance. But here's Mars, and I'm just going to go and turn off some of this other stuff in here as we get it in a little bit closer. Mars has 2 moons. So these little orbits here, those are the orbits of Mars's moons. Not like moons, like nice moons, like we have a pretty awesome moon. But these are probably more like just captured asteroids. So like those solar system bodies that we saw that just got a little bit too close. Kind of potato-y shape. They're not even really massive enough to pull themselves into nice spheres. So when things in space are massive enough, they pull themselves into spheres like planets. And they're not perfect spheres, like almost nothing is perfectly spherical because things are spinning, and so they get oblate, which means they're pudgy in the middle because they're spinning. Gas things tend to do that even more so than solids. But yeah, so here's Mars. So you can see some surface features, even from, way up here in space above Mars. There's these little, like, plippity-plip-plips. Those would be craters. So a lot of the round surface features that we see on Mars are craters, and then some of it is from volcanic activity. I'm going to try and spin the other way, see if I can do this, and kind of time our timer here. Yeah, so if we come around Mars, a couple of the big features we have this huge chasm, the Valles Marineris, named after Mariner. It was the first kind of spacecraft to fly by Mars and notice this nifty feature. And then if we come around here, we have more round spots on Mars. These are not craters, these are volcanic. Well, they're volcanoes, extinct volcanoes. So these are volcanic features. So some of the features on Mars are impact craters, and some of the features on Mars are from volcanoes. There's Olympus Mons, and then the volcanoes from the Tharsis region. There's another huge volcano around here somewhere. But you know, just because I can, I'm going to go ahead and turn on this other map of Mars. So we'll just kind of nerd out at Mars for a little bit and see some of the other features here because it's neat. One of the features that, there's some stuff I want to talk about, and then there's just this other neat layer. Because like I said, we have amazing maps of Mars. We have better maps of Mars than we have of our own ocean floor. So let me find... I found the map earlier during practice. Now I'm not sure. I'm gonna try this one. I don't think that's right. 1 minute. So if I can't find it, I can't find it. But let me try another map here. So right now this is our map. MOC, no, it's not what I want. Oh. Nope. 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 Yeah, a lot of these are not the one I want. Oh yeah, this is it. Okay, it's just taking a little while to come in. Found it. So pseudo color, I'll go ahead and turn off the other one. Ooh, okay, so yeah, so Mars isn't really like blue and green and everything. This is a height map. So it's showing elevation, so maybe not height map, but it's an elevation map. So you can see which parts of Mars have higher elevation, which parts have lower elevation. Ignore the other planets in the background. So the northern hemisphere of Mars is mostly like lower elevation. That probably used to be a big old ocean. So you can even see like some river deltas and things where, you know, liquid flowed. All kinds of evidence of like ancient, previous liquid water on Mars. So that's neat. So we're going back there to look for more of that and, you know, possible life and stuff like that. Yeah, so Mars 2020 rover Perseverance still, I don't know if that's still scheduled to launch. Maybe someone can let us know if that's still scheduled to launch this summer. Hoping yes. If I go ahead and turn around this way, here you can see a little bit more clearly now. So these things would be craters, these circles are craters, and now we can see with our elevation map that these are actually sticking up. And this is actually protruding out of the atmosphere a little bit. Those big old volcanic mountains. So a couple reasons that the northern part of Mars has kind of fewer craters. That's really what I wanted to talk about here was the craters. The northern part of Mars would have had an ancient ocean protecting some of it. And if we come in closer, I'll turn off the pretty colors. We'll do that again on Mars Day. We come in closer to Mars. You can see that it does have this thin atmosphere. Kind of roll over to the side. Oh, look at that. Very thin atmosphere. So Mars, being as small as it is, it's about a quarter the size of the Earth. It's pretty small for a planet. It still has this thin atmosphere. It has enough mass that it's held on to some atmosphere. It probably used to have a thicker atmosphere, but because of its low gravity, a lot of that has kind of escaped away into space. So one of the force fields, I like talking about these force fields that are keeping the Earth safe and protecting us from all the things in the universe trying to kill us. One of those is our atmosphere, and we have an atmosphere because of the force of gravity, yay for gravity, that basically holds this air really close to the surface of the Earth. So the air is on the outside, and then the solid and liquid bits are a little further down below the gas layers. So yes, the atmosphere is part of a planet. It's a really important part, and that's part of what keeps it from being so heavily bombarded. So I just said, oh yeah, Mars has an atmosphere, and so it shouldn't maybe be super bombarded, but I mean, we just saw all these massive craters on it. So um, if it didn't have an atmosphere, it would probably have even more craters. So yeah, Mars has a lot of craters and volcanoes, really great volcanoes. They're nice. Um, but if it had no atmosphere, it would have far more craters. I can pretty much promise you that. In fact, I can show you. So let's take a look. Let me see if I can find. If we look back towards the rest of the solar system. Yeah, I don't think that's the rest of the solar system. So I'm just gonna hold on, buckle up real quick. This is not gonna be a smooth transition. Okay, everybody buckled up. So we're gonna go back to not the sun, past the sun. But we're gonna come back towards Earth to our fancy schmancy neighbor in space, and the moon. So as you might know, the moon doesn't have an atmosphere. So it's not like it has a thin atmosphere like Mars's atmosphere that's like 1/16th, or it's like less than a tenth the density of Earth's atmosphere. But the moon has no atmosphere at all. Oh, but it's so glorious. Okay. So, but the moon is completely covered in craters. Okay, so Mars, yeah, had a lot of craters, but nothing like the moon that has no atmosphere to speak of. It has like trace elements, whatever, near the surface. Okay, fine. So, everywhere you look on the moon, craters. All right. So, even where you think there's no craters, I promise there's a crater. So, like, oh, look, here's kind of like the smooth area, but you still see like some craters there. And actually, the astronauts went there. They went like right out there and over here and up here and somewhere else. And they found like just all these micro craters. So even like as you zoom into the moon closer and closer, and yeah, we'll do that at some point too. You just see more and more craters. There's just craters within craters within craters. So even these kind of like smooth Maria areas, you're starting to see some craters in there. But there's even like micro craters the size of quarters. Like Mars doesn't have that. Like anything that small that would have come along and hit Mars would have burned up in the atmosphere. So yeah, the moon has other stuff. Like it has mountains, these glorious mountains. Oh, look at that. And it has, the Maria and everything. But everything is covered in craters, regardless. Like even if they're teeny tiny, like micro craters. So that's what happens when you have no atmosphere whatsoever. You get pelted, just like bombarded with like every little rock and pebble. Forget the big stuff. Like everything just smashes into it and leaves a hole. Well, the same thing is actually happening to Earth. That the Earth doesn't look like this because we have our fabulous force field. Let's see if I can find the Earth. Probably not. Oh yeah, no. Yeah, the Earth was back over behind the moon. There's the Earth. Oh, Earth. Yeah. So the Earth, let me zoom into that. Earth. Here we go. So all this stuff, and actually more stuff than what hits the moon, is hitting the Earth every day. So I talk about all these microcraters, like the whole surface of the moon. Think about that. Entire surface is covered in microcraters. And even more stuff is hitting the Earth every day. I looked it up. According to NASA, over 100 tons of material. I'm guessing those are like British pound tons, not metric tons. They just said 100 tons, and it wasn't with an E. So 100 tons of material are hitting the Earth every day. Every day. But, the atmosphere is part of the Earth. So it's hitting the atmosphere, but just because it hits the atmosphere doesn't mean it doesn't hit the Earth, because the atmosphere is a very, very important part of our planet. That's part of this like shield that keeps things from reaching like where things are trying to live. So I'm gonna try to zoom in here and get this nice like crescent of a, oh yeah, that little atmosphere. It's so thin and it's so dainty. I mean, you can literally like swing your hands through it. Like, do it just right now. And we take it for granted, I think. I mean, you just like wake up each morning and you're not suffocating because, oh, there's air, because gravity holds our atmosphere down here, which is really nice. So yeah, so even though there's a lot of stuff like coming along and hitting the Earth, um, we do get some things that make it through the atmosphere, and they leave impacts every now and then. Um, every several tens of millions of years. Sorry, this is data still loading. Trying to not break this. Um, every now and then we get like that extinction level event, like we had about 65 million years ago. That was bad for the dinosaurs. Not bad for us. I mean, we're here now, more or less. Um, but yeah, but we do have some big craters that have been created by impacts. A couple of them in the U.S. Well, there's the big halfway underwater crater by the Yucatan Peninsula. So that's the one that was like really bad for dinosaurs. Um, back in one of my former home states, there was the meteor crater in Arizona. That's like a big, that's more recent one, and one that I didn't even know about. Like I used to visit Maryland all the time when I was little. I didn't realize the Chesapeake Bay has a giant impact crater. Yeah, Chesapeake Bay. Who knew? I guess the people who dig for stuff down there, they knew. Anyway, that's my version of the universe is trying to kill us. I don't know if anyone had any questions or any requests, anything else people want to see, anything more hopeful, other than like the universe is trying to kill us, but we have an atmosphere, so we're not dead yet. Um, in that case, we'll take a look at some constellations, just because we can. And let's see, constellations. Yeah. All right. So we're actually kind of looking over towards Hydra right now. So I can do this neat trick where I actually turn off the Earth. Earth, gone. Actually, yeah. And what's left? Actually, there's this little shell left. That's the atmosphere. So we'll turn that off too. But yeah, so somewhere over there, and I'm just kind of curious because I didn't try this earlier, so I'm kind of curious to see if this will work. But somewhere over here ish, because we're looking towards the constellation Hydra. So all along here, this long snaky thing, that's Hydra. All the way up to, it has a head up here somewhere, whoosh, all the way up there. So it's kind of like this little round circlet, and then it zigzags all over that part of the sky. And there's a couple constellations like that. They kind of crack me up because it's almost like there were, just some stars left over between some other things, and you just kind of, connect the dots and and connect everything that's there. So there's like a river, and there's serpents, two pieces of it, and Hydra. And T answers says, space agencies are monitoring these asteroids, but what can we do if an extinction event asteroid is headed our way? Yeah, that's a good question. So I'm not sure exactly what all they have up their sleeves. Some of the things like that we've seen in movies don't work. I can tell you that much. So we're probably not going to hit it with a bomb because yeah, the whole Armageddon thing, that I don't think that actually works. Um, but I think one thing they could do is try to paint it. Oh yeah, I bet it's this one. So one of these. Okay, one of these, because I don't think there's labels for this. Okay. I'm just going to turn on time so we can see this. Yeah, so one thing we might be able to do is like paint it and try to get a little bit more of it, like one side of it more reflective. So I think some of it would depend on the trajectory, like how close it's going to be, how fast it's going, how much advance notice we have, and yeah, we'll just let these zoom by. And if we could make one side slightly more reflective, then the sunlight reflecting off of it could almost help like nudge it just a little bit. Another thing we might consider is like trying to fly something nearby it, like try to get some other big mass nearby, and have some masses like kind of programmed to fly on a certain side of it instead of like orbiting it, because that would those forces would cancel out. So we could maybe use gravity to tug it like a little bit off course. Um, Lasers probably wouldn't work. Sharks. I'm gonna go no on sharks. But I think those are some of the um, more probable ways that we could try to deflect an asteroid. But that takes time. So really, if something snuck up on us like this week, like yeah, it's not gonna happen. But if we know like a few years in advance, we can launch something, get it out there, nudge it away. So yeah. So if we have more and more capabilities to launch things into space, we have more private industry that's able to launch things. So the more ability we have to do that, the better. Kind of along those lines, something else that I could just show you real quick. We come back in towards Earth. There's one other thing that I usually turn off. It's kind of a default that it's usually on at the beginning, um, and I just turn it off. So I may have mentioned, I don't know if I've mentioned that there's people living in space. Everyone know there's people living in space. There's people living in space, um, and maybe I need to turn on the Earth so we can see that better. Earth. Yeah, we want that, and we'll turn on the atmosphere because it's awesome. So this is the ISS, the International Space Station. Well, at least it's the orbit. The ISS is like really small. But yeah, so there's been people living in space for a while. Like we really do live in the future. Like there's people in space, and one of our planets is inhabited by robots. Like, oh, and there's UFOs apparently. So yay for 2020. Um, but one thing, I'm just going to see if I have it because I'm not actually sure that I do. So just kind of bask in the ISS. Oh, oops. That was way too fast. Sorry. Won't let it happen again. Um, that's still too fast. But there's lots and lots of other, um, there's lots of other satellites up there. I mean, there's, the whole Starlink, and uh, there's, yeah, here we go. Starlink, there's weather satellites, there's navigation satellites, there's science stuff. So I'm just going to start turning stuff on. There's some geo satellites, there's some GPS satellites. I think those are further out. Yeah, and these are just their trails. There's stations. There's a few more. Whoosh. Okay, so a lot of these are out like at a higher orbit. So those kind of yellow goldy ones. These are at a special orbit. It's a geosynchronous orbit. So those are around 24,000 miles out. And there's a bunch of stuff closer in, and then there's a whole mess of stuff like really close in. And here, if I turn on the trails, um, just a few minutes. Wow, that's a lot of stuff. And that's just some of them. So there's so much stuff in near Earth orbit. At some point, I mean, yes, space is big, but it's not infinite. And near Earth orbit is big, but it's even less infinite than space. And if we have too much stuff in near Earth orbit, it's going to make it really hard to fire off that rocket to stop that asteroid, because really it's not if but when. So yeah, we have some cleaning to do. Cleaning up down here, cleaning up there, or at least not letting it get too overly polluted so that we can't send a rocket to intercept an asteroid that will eventually come for us. And the atmosphere won't be quite enough to stop it. So on that happy note, I'm going to wish you a happy Thursday, and thanks for the question, and we'll be back next week. If you have requests, feel free to leave in the comments, or just bring them next week. Thanks, and good night.